Hello Hardchill, today we will be looking at distance time graphs and hopefully we will be able to interpret distance time graphs by the end of this lesson. Your keywords for this lesson are axes, distance, gradient, change, straight line, speed, time and units. Okay, so here we have a distance time graph with 5 different lines representing 5 of the pictures on the side of the screen, and we need to be able to match the pictures up to their respective graphs. So if we have a look at the first person, we see a man who is just casually walking. Now we need to make some sort of judgment on how fast we think this person would walk compared to the other items. So because he is walking quite casually, so it will take him in the same amount of time, he will only cover a smaller distance, so he will be matched up to the bottom line. Okay, now if we look at the other 4 options that we have, the next I would say the person to be the quickest would be the man that is running. He wouldn't be quicker than the cars and the dog, but he would be quicker than the man walking. So then E will match up to that line. Okay, now we are left with the dog and the 2 cars. Now, I think the dog would be the next quickest compared to the 2 cars. So B will match up to that. And then we are left with the 2 cars. Now, the 2 cars, one is a sports car, C is a sports car, and D is just your standard car. Now, you would assume that the sports car would go quicker, so it will cover more distance in the same amount of time. So the sports car will be our top line, and the normal car would be the blue line. Okay, and that is matched, all the lines to the pictures. Okay, so as you should remember from last lesson, that is the formula triangle for speed, distance and time. So if we have a look at these 2 lines, the blue line indicates someone at a higher speed because they are covering the same amount of distance but in quicker time, and the line at the bottom would show someone in the lower speed. Okay, if you look at the next graph, the red line indicates a slower speed or a lower speed, and the blue line indicates a higher speed because the gradient or the line is steeper. So steeper it is, the quicker or the higher the speed is. So how can you use a distance time graph to find out speed? We just need to find out the gradient of the line, and that will tell us the speed at which the object is travelling. So having that in our minds, if I wanted to work out what the speed was, say for the first 2 hours of that journey, I would have to work out the gradient of that line. So if we're just interested in this part and the speed here, we know speed will be our gradient. Now, gradient, calculate gradient, is the change in y over the change in x. So the change in our y-axis, which is here, over the change in our x-axis, which is here. So our distance is our y-axis, which is represented by 12 miles. And our time, which is represented by the x-axis, is 2 hours. So 12 divided by 2 is 6. And remember our units from last lesson, it will be miles per hour. Okay, so that's all we have to remember, that if you're working out speed from a distance time graph, we just have to work out the gradient of that line that we are interested in. So moving on, let's have a look at this one. Calculate the speed in the following distance time graph. Now remember, speed is gradient, so if we just pick 2 easy points to read off, so if I pick that point and say that point, I will now be able to work out the speed, by working out the gradient of that line. So remember, speed is gradient. So speed will be change in y over change in x. So if you look in here, our change in y from 60 to 20 is 40. And our change in x, our timing, if you look at that, that is half an hour, and this is 1.5 hours. So the time is only 1 hour. So we got 40 miles over 1 hour, therefore the speed would be 40 miles per Okay, we'll give yourself a minute now to calculate the speed of this journey. Remember, speed equals gradient, and gradient is change in y over change in x. Okay, I will go through it now. So we should have picked two easy points. I'm just going to pick this one here and this one here, and make a little triangle because that will help us with our gradient. Now, remember, speed is gradient, and gradient is change in the y direction, which is here, which is 40 miles, over the change in our x, and our x is in hours, and that is 4 hours. Therefore, 40 divided by 4 is 10, and is 10 miles per hour. Okay, the next thing we move. Okay, you will also be asked to interpret a speed, distance, time graph. So, if you have a look at the following graph, it asks us how far did he run in 3/4 of an hour. So, looking at the bottom of the graph on the x-axis, which is relating to hours, all we have to do is find out where 3/4 of an hour is placed. Now, you look here, it goes all the way up to 1 at this point. So and it's going up in quarters. So that will be a quarter, that would be a half, and that would be 3/4. Okay, and it's asking us how far did you run in terms of distance. So if you draw a line up and then cross to the y-axis, and that is a number 8. So he therefore ran 8 kilometers in that time. Okay, then it asks for his speed in the first hour. Okay, so to work out speed, let's remind ourselves, it is the gradient of that line. So for the first hour, here is our line. We'll draw a line upwards and across, and we've got our little triangle. Now speed is gradient, so change in y over change in x, so it'll be distance divided by time. The distance covered in the first hour is 10, and obviously the time in the first hour is only 1 hour. Okay, and therefore the speed will be 10. Okay, because the distance is in kilometers, time is in hours, it will be kilometers per hour. Okay, it also says how long did you stop for, so you are looking for a straight line. And you can see here, this is where we have that straight line. That means there's no gradient, there's no speed, because the car is stationary, the person is stationary, and the time that this person is stationary for is 1/4 of an hour, which is 1/4 of an hour, which is the same as 15 minutes. Okay, and it says how long did it take him to run the whole 40 kilometers. So if you go across to 40 and then read it off to the bottom, because that is the time, you will see it takes him 2 hours and 3/4. So it takes him 2 3/4 hours, which is the same as 2 hours and 45 minutes. Now this is your task, and you will have questions to answer. If you look on the side, you have 4 questions, and you need to take a picture once you've answered these questions and upload this to ClassCharts. Thank you.